Let me introduce Szabolcs Csepregi, also many of you already knows. He has a PhD in cheminformatics and worked as a programmer and program designer in his previous workplaces. He joined ChemAxon in 2003 and originally also developed Marvin, some parts. Then now he is the director of search technologies, and since 3 years, 2-3 years also the head of the Markush enumeration. Today he will talk about the search engine of ChemAxon, the backend of JChem Base, maybe how it fits into these race cars or something like that.
The race cars are from the Formula One, and this is just a nice illustration to say that, okay, yes, we are really speeding up JChem further, as you will see, and also that we are introducing formula search into JChem Base as well. First of all, I would like to ask how many of you have used JChem for searching? Hands up, please. Okay, that's quite good. Because first of all, I will talk about the JChem backend tools, which do the chemical searching in JChem. I will describe what these backend products contain, and I will also talk about the recent developments. So the JChem family inside the ChemAxon's product suite consists of the JChem Base, the search engine, which is basically the search engine part, and this one is embedded into all the other chemistry searching applications. The cartridge integrates into Oracle, and we have Markush Search and JChem Web Services as add-ons. We also have a few user interfaces for these databases. Instant JChem and JChem for Excel are the more traditional user interfaces, but we have just launched JChem for SharePoint this spring. And this is the development team for the JChem backend. JChem guys and search engine and Markush guys, please stand up so that people can have a look at you. They are hiding in the back. Yeah. Okay. So what can we do with these database tools? We can import many different chemical file formats, including the industry standard mol files, SMILES files, the IZ sketch and ChemDraw CDX formats, and so on. Last year we have just introduced the Markush Dark file format that Timmy will talk and Brian will talk about further today. But we can also import any other chemical structure formats that are supported by Marvin, including UPAC and traditional names. JChem Base can talk to different database engines as well. So we are not limited to Oracle, but MySQL, Derby, or Microsoft SQL Server, and so on, can all be used to store the chemical and non-chemical data. And finally, we can be interfaced through many different ways. We have a Java and .NET programming interface. We have an SQL interface through the Oracle cartridge. And we also provide web services interfaces. About the features, I don't try to attempt to describe all the features because we have so many things here, but just to highlight that how different things are available. The search engine is really versatile, packed with features. We have a very long documentation about it. In addition to the different features that are handled, we have many options that can fine-tune the behavior of the searching. So with this, you can customize the different search behaviors to suit your needs. For example, we can ignore the stereochemistry or different chemical information, or we can search for tautomers and so on. And this is just the list of the most important ones. Okay, a slide about the performance. We haven't updated this slide for a long time. It is still using JChem 5.2. I think these data are 3 or 4 years old. We haven't updated these because these were already quite fast, and we have just been faster since then. But some newer machines have come out since then. But you can see that it is possible to do quite large chemistry database searches within seconds. Okay. The different table types, what kind of chemical information can we handle? We can certainly handle molecules, we can handle reactions. In the reaction tables, we can do reaction similarity searching and special reaction search features. We have query tables as well, so we can store chemical queries. And we have the any structure, which is a Joker table type. And more recently, we are also handling Markush structures that Timmy will talk about later. Okay. We have many example web applications in the JChem distribution. 2 examples are here. The Java server example, Java server pages, and the Ajax examples are part of the JChem distribution and are easy to use and customize. In the JChem backend products, many other ChemAxon products are also integrated. For example, the standardizer can be used to bring the diverse chemical representations into a standard format, or we can use the calculator plugins to populate additional columns in the chemistry database, so we can automatically calculate different chemical properties for the inserted structures. And we can also use the calculator plugins for filtering search results. So for example, drug likeness filters and the like can be easily applied to search results. The screen products provides alternative similarity search techniques. So for example, we can do a pharmacophoric similarity search with screen, or an ECFP algorithm can be used for similarity searching, and so on. We have various tautomer supports. There are 4 different alternatives for searching tautomers. I will not go into detail now. And finally, Marvin is the drawing and visualization package, which is 100% compatible with all JChem chemistry features. The cartridge not only offers an interface to searching, but it also integrates many other things into the Oracle engine. For example, we can provide reaction-based enumeration and Markush enumeration right within Oracle. Format conversions, even images can be created from the Oracle database, and also the property predictions are also available in the cartridge. A quite large proportion of our development efforts are going towards Markush structure handling. In the afternoon and on the full Thursday morning, we will have a lot to talk about this, so I will just skip these. And let's see what's new in recent JChem versions and JChem backend. First of all, the search engine. The 5.4 version was released like the beginning of the year, and it brought in a new hit visualization for similarity search results. Here we use a maximum common substructure algorithm to highlight the similar parts from the query and the target structure. I will show some examples of this later live. We have also improved the R group tables for R group decomposition. So in case of the symmetrical scaffolds, the R tables are more logical and consistent. We have enhanced the multi-threading in the backend. It means that the first results will appear faster, and the similarity search is also performed in parallel now in the database. We have enhanced tautomer duplicate tables. Now they can not only perform tautomer search, but the traditional duplicate search is also available for this kind of tables. We also introduced a new stereo search option. We can now search for enantiomers, which will give back the exactly same stereoisomer and the enantiomer as well. This search option joins the dial stereomer, ignore stereo, and so on, other stereo search options which were already available. Finally, we have just introduced the extended connectivity fingerprints for similarity search, and these also have a pharmacophoric version as well. These are very popular, so it was a popular demand. We just released the 5.5 version, where the search engine provides now a sophisticated formula search. In JChem, we have always provided chemical formulas for the structures entered into the database. Now this is a quite comprehensive way to search these formulas. In this formula search, you can use the order of atom types in any order, or you can use intervals, you can exclude atom types, and you can specify components, salts, polymer formulas are handled, isotopes, and so on. So it's really quite comprehensive, and it offers much more than the previous string processing of the chemical formulas. We have also introduced some new stereotypes to the searching. For example, syn-anti-endo-exo stereochemistry can now be handled. This is related to these bicyclic ring systems. And we have also introduced a cis-trans information of cumulants, and also axial stereochemistry of atrop isomers, when the substituents here don't allow these rings to flip over. Okay, these latter two are not yet working on the database, only in memory searches, but in the next release we'll introduce the database support as well. And by default, all these new stereotype searchings are switched off. So if you would like to try them, you have to look for the search option and switch them on, and you can play around with them. We have also improved the R group searching speed. Now we use the R group definitions information in the screening step as well. So this way the R group searches in molecule databases have been enhanced quite greatly. Depending on the R group query and the database, even 100 or 1,000 times speed up can be achieved here. Okay, Regarding other features of JChem Base, we have introduced a new table option, duplicate filtering. When this option is switched on, then we do not allow any duplicates entered into the database. So it will be a filter on the JChem table or the JChem index. In JChem Web Services and in the Ajax example, we have introduced JChem Manager functions. So it is possible now to create tables and import and export structures within this Ajax interface. In web services, we have also introduced some new functions like searching in lists of molecules and export related table data, and also some batch operations. And also the Markush search and enumeration features have been enhanced in the web services and in the Ajax example. There are lots of improvements in the Markush search front. I will not detail this now because on Thursday we will have a very detailed discussion of all these, and just the newest features as well. Again, a very significant speed up has been achieved for Markush structures, and we are also supporting very large combinatorial Markush structures with thousands of R group definitions. Okay, and let's see what is in the pipeline. We have many plans for the Markush search. Again, I will not detail these now because Timmy will talk about these, and we will have all Thursday morning about these. But in JChem Base and Cartridge and web services, we also have many things planned. For example, we are planning to provide a computational cluster support. It can use many computers in the backend to speed up the searching. This is especially needed for our Markush project, so that the full patent literature could be handled efficiently. We are also planning a maximum common substructure search type, not just for, it is already available for single molecules, but we also plan this in relation to Markush structures. So this will be quite exciting. We are adding R group decomposition into the user interfaces, into the Ajax example and the Instant JChem, and we are also creating an interface in the cartridge. In the R group decomposition, we are also planning to create new layouts when not the traditional tabular, but the results are aggregated into a pivot layout. We are also planning to introduce JChem indexes into JChem Base. So far, these have only been available in the cartridge, and this will allow arbitrary table structures to be used from Java API and .NET API as well. And we are also planning improvements for the cartridge installation, so a one-click installer will come for the cartridge. And I would like to show a demo of these newest features. So I will switch over to Instant JChem, where I will first of all, so I wanted to do a similarity search. Okay, just for the highlighting of the MCS. Can you see the structures? So the similar, the maximum common substructure portion with my query is highlighted, and also the similarity score is displayed in the corner. Okay, then I will delete this structure and draw a substructure query. Now I will use these homology groups. I will use a shortcut for alkyl. Okay. Sorry, I didn't want similarity, but substructure search. Here we have a benzene connected to an alkyl. Okay, but you may say that, hang on, but this alkyl is substituted. So I will put S star there, which means substitution as drawn. Okay. So these are all the benzene structure with unsubstituted alkyls. Hang on, these are all methyls. So let's just say that I'm putting some properties for these homology atoms. Now I'm interested in branched alkyls, which are low or middle alkyls. Okay, let's have a look at these. Okay, there we go. We have some nice larger branched alkyls. Okay, let me just put substitution here. I will add a position variation bond here. So I will say that I require an oxygen to be positioned to any of these positions here. Let's have a look. There we go. Okay, it's highlighted. Okay. Another example. Okay, I will just draw these substituents. I will draw another homology group. Oh, by the way, these homology groups can be entered and many other query features in this periodic system window in the advanced tab. Here are the different query atoms and the query properties. Here you can specify the number of hydrogens, the ring bonds, and so on. And here are the homology groups. This is the alkyl and so on. And the new one I wanted to show you is the ring segment, or in short, the XX homology group. Unfortunately, it's not yet in the list, but I will just put it here as a pseudoatom. And let's see what it retrieves. So basically, it retrieves all the rings that close here. So anything that closes a ring here is retrieved. And again, I'm adding some homology properties to it. In this time, I will put in some text nodes here. Okay, what are these text nodes? I will put that I want oxygen here, 0 to 1. I will want a carbon, 1 to 4. And I want nitrogen, 1, 2, 3 pieces. Okay. Okay, it's quite a specific ring closure here. So let's see. There we have. Okay, it's not highlighted, but yeah, we can see 0 to 1 oxygens. That's fine. 4 carbons and 1 nitrogen. Again, similarly, all these other rings are fine. Okay, let me just draw another query. How am I with time? Okay, last one. This will be a again a substructure search. Okay. And what I wanted to show you the tautomer searching option. I switch on the tautomer searching, then I will also retrieve the tautomers of this structure. Okay, so in summary, the JChem backend, the JChem engine is quite comprehensive. It supports lots of interesting searches. It's also efficient, it's quite fast. It's a good team player. It's open to integrate into other products and other inside and outside ChemAxon. And it is under continuous development, and there are a lot of improvements in the pipeline that have come out recently. Okay, I'm ready for your questions. Thank you.
Thank you very much for the presentation. We have time for 2 or 3 questions. I've seen that you increased the speed of this R group search. Maybe it's the part of the Markush search speedup, or it's a separate project?
This time it was a separate project, but as a result, we could also allow some simple R group searches against Markush databases. So now it's a new feature in Markush as well.